Hi everyone, myself Bidyutlata Sahoo, working as an assistant professor in the Department of CSC, Artificial Intelligence and Machine Learning at Institute of Aeronautical Engineering, Hyderabad. Today I am going to discuss about the knowledge-based agent. These are the topics to be discussed today. The first one is the logical agent, then knowledge-based agent, key components of knowledge-based agent, why knowledge-based agent is required, example of KBA or the knowledge-based agent, the architecture of knowledge-based agent, what is knowledge base and what is inference systems, what are the operations performed by KBA, the levels of KBA, what are the approaches to design KBA, and as well as few applications of the knowledge-based agent. Let us discuss about the logical agent. A logical agent, it is an intelligent system that makes decision based upon the logical reasoning. Here the two words are used. One is the logical, another one is the agent. We need to understand what is the meaning of an agent. An agent is something, it may be a human being or it may be a software or it may be a machine, which can perceive the information from the environment through the sensors, and based upon the information it can process it as well as it can perform the action onto the environment through the actuators. That is called as an agent. But here the term is logical agent, the agent which performs the action logically. That is why it is called as the logical agent. So basically it is related to the machine, which is nothing but the intelligent machine. So that is why it is given as logical agent. It is an intelligent system that makes the decision based upon the logical reasoning. So reasoning means the application of the methods or the axioms or the rules to process the information which is stored inside the agent. That is why it is called as logical reasoning. And why this logical reasoning is used? To solve the specific problem or to achieve the goal. It uses the knowledge representation and inference mechanisms to derive conclusions and take appropriate actions in its environment. It uses the knowledge representation, as we already know that the knowledge can be represented in various ways in artificial intelligence. It may be the proposition logic, means the logic representation, and your first order predicate logic representation. Knowledge can be represented using frames or using semantic networks, using ontologies. So it uses various logical knowledge representation techniques as well as the inference mechanisms, the mechanism which is used by the logical agent to derive some conclusion from the set of premises. That is why it is called as inference mechanisms, to derive conclusions and take appropriate actions in its environment. The knowledge is typically represented in the formal logic such as proposition logic or first order logic. Proposition logic and first order logic both comes under logical representation. Then let us discuss about what is knowledge. Knowledge is the basic element for human brain to know and understand the things logically. Like when a person becomes knowledgeable about something, he is able to do the things in the better way. If you have the good knowledge about a particular subject, definitely you can do better in that subject. That is what the knowledge is required. But along with the knowledge, two more things are also required, which is called as the intelligence and reasoning for any agent, irrespective of any agent. Maybe the human agent or maybe it may be the machine. Now in AI, the agents which copy such an element of human being are known as knowledge-based agents or knowledge-based systems. So these are the agents which is having the knowledge like human being. That is why it is called as the knowledge-based agents. Like our robot. Robot is an agent having the knowledge. The knowledge of human being is incorporated inside the robot. That is why robot can behave or robot can move like a human being. Robot can perform the operation like a human being. So for efficient decision making and reasoning, an intelligent agent needs knowledge about the real world. So why this why the knowledge-based agents are required for taking the decision and to understand the knowledge to derive the conclusion or to derive the goal. That is why the knowledge-based agents are required in real world. Now, what is knowledge-based agent? Knowledge-based agents are those agents who have the capability of maintaining an internal state of knowledge, reason over that knowledge, and update their knowledge after their observations and take actions. That means the agent or the robot or the machine, you think about the robot or you think about the Alexa, who have the capability, automatic capability, they can maintain the internal state of knowledge, they can represent the knowledge automatically using different knowledge representation techniques, even they have the capability to understand or to reason over that knowledge which is present inside the agent, as well as they can learn and they can update the existing knowledge using after observing the environment, and based on that it can perform the action and it can take the action. So these agents can represent the world with some formal representation and they can act intelligently. That is why they are called as intelligent agents. Now we'll see what are the key components of the knowledge-based agent. Basically, there are two key components of any knowledge-based agent. Here in this picture, you can observe main two components are there. One is the knowledge base and the second one is inference engine. And the diagram, it shows that it is completely divided into two parts. One is the offline part, another one is online part. So this knowledge base comes under offline and this inference engine comes under online. Why it is called as offline, why it comes under online, that we need to understand. As it is called as the knowledge base, it is like a base where the knowledge can be stored. The knowledge which is acquired by the agent can be stored inside this knowledge base. And what type of knowledge it stores and when it stores, basically the knowledge base is used to store the prior knowledge before the execution of any action, or the past experience or past information or past data are stored inside the knowledge base. That is why it comes under offline, because knowledge base does not interact with the real world environment time to time. That is not the work of knowledge base. That is why it comes under offline. Whereas the inference engine, the name itself specifies that it is a kind of engine which is used to infer something from the knowledge base. So this inference engine takes the help of the knowledge base. That means it retrieves the knowledge from the knowledge base, as well as it observes based upon the observation for the agent, based upon the goal of the agent, and based upon the knowledge which is present inside the knowledge base, it takes the decision as well as it performs the action. How it performs the action? It interact with the real world. And it performs the action. That is why it comes under online. So two things are there. One is the knowledge base, another one is the information engine. Knowledge base, it is only to store the knowledge which can be further used by the inference engine. Inference engine which is used to derive the conclusion, or which is used to take the action, or which is used to take the decision based upon the knowledge which is stored inside the knowledge base, based upon the goal which is the goal of the agent, or based upon the observations from the agent. That is why it is called as online. So we'll see one of the example of this knowledge based agent. A medical diagnostic system. It is the agent like the Alexa or like the robot. Here the medical diagnostic system, it is the agent which uses the symptoms. Symptoms are nothing but the facts or which we cannot change. Like suppose if anybody gets COVID-19, then he or she must have the symptoms would be fever or cough or cold. That is the fact. So those are the symptoms, and the medical rules, which is called as the knowledge, which are stored inside this agent to diagnose the diseases. That means what it can infer this agent. The name of the agent is medical diagnostic system. It uses the symptoms which are nothing but the facts, and the medical rules, which are called as the knowledge, which is stored inside the knowledge base. By using this, it can derive the conclusion or it can derive the result as diseases, which is called as inference. So this is the simple example of any knowledge based agent, how it can infer the result from the existing knowledge. Then why the knowledge based agents are required? What property it should behave? So a knowledge based agent must able to do the following. An agent should be able to represent the states and action. Every agent, as I told, as I have informed, like in the first time, any agent, it may be the machine agent or the robotic agent or a human agent, any agent should be able to represent the state and the action where it is present, that is the state, and the action, what type of operation it can perform, that it should have the capability to represent. Second one, an agent should be able to incorporate new percepts. That means every agent should have the capability for or to incorporate new perceives. It should have the capability to receive the information from the environment automatically. An agent can update the internal representation of the world. Every agent, this is also one of the property of any agent. It should have the capability to update the internal representation of the world, how the knowledge is stored inside the knowledge base. It should have the capability to represent, as well as it should have the capability to modify also. An agent can deduce the internal representation of the world. Deduce means it should have the capability to derive some conclusion from the set of premises or from the existing knowledge, as well as it should have the capability to minimize the knowledge if the knowledge is overloaded inside the knowledge base. An agent can deduce appropriate action. An agent should have the capability to perform or to take the decision for necessary action. So these are the capabilities of any knowledge-based agent. This is one sample example for knowledge-based agent. Suppose a knowledge-based agent in a smart home has the following knowledge. These are the two knowledge which are already stored. We have to think in that way. If the temperature is above 28 degree, the air conditioner should be turned on, and the current temperature is 30 degree. These are the knowledge which are stored inside the knowledge base. Now what the knowledge base can infer? The knowledge base can derive the conclusion from the set of these two knowledge. It would be turn on the air conditioner. Why the result would be turn on the air conditioner? Because the current temperature is 30 degree, and it will compare the knowledge, what is the knowledge which is present inside the knowledge base if the temperature is above 28 degrees. So which contradicts this statement. That is why the inference engine will derive the conclusion that turn on the AC. Let me discuss about the architecture of knowledge-based agent. You can see this diagram where two important components which I have already introduced. Again, I will repeat this one in this diagram. One is the inference engine, another one is the knowledge base, and one more important component here, it is added as the learning component. So include these three, including this inference engine, knowledge base, and learning component, which constitute as the knowledge based agent. So what is the work of knowledge based agent here? So the work of KBA or the knowledge based agent is, as it is a agent, it has the capability to receive the input from the environment through the sensors, and that input will be inserted into the inference engine to the knowledge base. So where the knowledge should be stored? Actually, the knowledge should be stored inside the knowledge base, but it will come through the environment, through the inference engine, it will come to the knowledge base. So that is the first step of the knowledge based agent. It receives perceives all the informations from the environment through the inference engine, and the knowledge will be stored inside the knowledge base. After storing the information or the current data inside the knowledge base, then the work of inference engine is to extract the knowledge from the knowledge base, and based upon the knowledge and based upon the current information, it will take the necessary decision, as well as it will perform the action also. That action is nothing but the output. And one more component here, it is there, the learning component is very important for any knowledge based agent. what is the work? Updating the knowledge base. The main goal of this learning element is whatever the knowledge is present inside the knowledge base, it gets updated continuously by this learning element. That is why all the three components, inference engine, knowledge base and learning component, together constitute the knowledge based agent. Now we should know what is knowledge base. Knowledge base is required for updating the knowledge for an agent to learn with experiences and takes action as per the knowledge. As I have informed, knowledge is important. So knowledge base is nothing but it likes a container like the database where the data is stored. Here in AI, knowledge base is the base, or else it is a container where the knowledge from the environment, knowledge from the expert, knowledge from the researchers, knowledge from anybody can be stored inside the knowledge base using various representation techniques. And it should be updated also by the learning element. And the knowledge base, it is the central component of any knowledge based agent. That is why it is called as KB, or the knowledge base. It is a collection of sentences. Here the sentence is a technical term and it is not identical to the sentence in English. That means what the statement says, it is a collection of sentences. Whatever the real world knowledge we used to talk in the form of English language, it is not similar to the English language, similar to the normal statement. It gets converted into different representation technique, maybe the propositional statement, or maybe the first order predicate logic statement, or maybe in the form of graph, which is called as the semantic network, or in the form of table, which is called as a slot and filter. So like this, the data can be stored, or the sentences can be stored inside the knowledge base. These sentences are expressed in a language which is called as the knowledge representation language. So different languages are used, as I just now I have informed, or I have told, like the propositional logic or the predicate logic, even web ontology language also we can use to represent the knowledge inside the knowledge base, which can be shared over the internet also. The knowledge base of knowledge based agents stores the fact about the real world. It not only stores the fact, it also stores the rules, stores the axioms, stores the general knowledge, but not in the form of English language, in the form of different representation technique which are used by the knowledge based agent. Now, what is an inference system? From the name we can understand inference system. It is a system first which is used to derive the conclusion, or which is used to derive the new sentences from the existing sentence or existing knowledge. So inference system allows to add the new sentences to the knowledge base. It can derive the conclusion. It helps to take the decision. It also helps to add the new knowledge to the knowledge base, or new sentence to the knowledge base. A sentence is a proposition about the world. What is the meaning of proposition? Proposition is nothing but the sentence can be true or it can be false. So that is called as the proposition. Normally in artificial intelligence, the sentences can be represented using proposition logic by using few connectives, as already we know, like disjunction, conjunction, implication, negation. So all these symbols we can use to represent using proposition logic. So sentences are called as the propositions about the world. Inference system applies the logical rules to the knowledge base to deduce the new information, and the inference system generates new facts so that an agent can update the knowledge base. An inference system, mainly it works in three rules. So what are the three rules? One is the forward chaining, second one is the backward chaining, and third one is proof by resolution. So forward chaining says that it starts from the initial state of the problem till the solution, and backward chaining means from the solution going back to the steps of what we take. And third one is the proof by resolution. It is where we will use the proposition logic. So these are the three rules using which the inference system works to derive the conclusion. Sometimes it not only the inference system, as I have told, it not only used to derive the conclusion, sometimes from the conclusion also it observes the initial step, which is nothing but the observation. So that is why by the first one is forward chaining, which starts from the initial state of the problem till the solution. That means it starts observing the things from the knowledge and tries to derive the conclusion or derive the goal. That is called as the forward chaining. Backward chaining from the solution going back to the steps of what we take. That means from the solution would be there, the goal already it has been achieved, but what would be the observation, what has been done by the agent, that can be derived using the backward chaining process. And proof by resolution, it is where we will use the proposition logic, like your negation, as I have just now I have told, negation or your implication, or it is your conjunction or disjunction. Now, what are the operations performed by the knowledge-based agent? Basically, there are three operations which are performed by the knowledge-based agent in order to show the intelligent behavior. So, these are the three operations. One is the tell, another one is the ask, third one is the perform. So, tell operation tells the knowledge base what it perceives from the environment. Ask operation asks the knowledge base what action it should perform based upon the existing knowledge. And perform operation tells the knowledge base that it performs the selected action based upon the decision. So these are the primary three operations are performed by the knowledge based agent. What are the levels of KBA? So there are three levels of the knowledge-based agent can be viewed at three different levels. One is it can be viewed at the knowledge level, it can be viewed at the logical level, it can be viewed at the implementation level. I hope we can understand from these three words. The knowledge level, at the basic level we can say we have knowledge but we are not applying any reasoning. That means say blindly we will try to find out the result. The result may be to find the result it may take long time or it may take long process. That is nothing but your knowledge level. We have knowledge but we are not applying any logical reasoning. Second step is called as the logical level, where the agent or the human being can apply the logic to find out the result or to find out the goal. And third one is the implementation level. After like implementation, some knowledge is there, it will be implemented using the pseudocode or it will be implemented using some language to derive the goal or to derive the result. So these are the three levels every knowledge based agent can be viewed at three different levels. Now we'll discuss one by one. The first one is the knowledge level, how the knowledge based agent is viewed at the knowledge level. So knowledge level, as it is the first level of knowledge based agent, and we need to specify what the agent knows and what the agent goals are. So first thing here, it specifies what is the existing knowledge inside the knowledge base and what is the goal of the agent. These two things needs to be known in the first level, and with this specification we can fix its behavior also. Now you can see the example, I hope you can understand. Suppose an automated taxi agent needs to go from the station A to the station B and he knows the way from A to B. So this comes at the knowledge level. That means some person, we are coming from our home to the college. Our home is A and college is B. We have the knowledge. So blindly I'll take the route and I'll reach the college. That route may be the longer route, it may be. It may not be the shortest path, but I know only one route. So with my knowledge, I can move from the source, from the home to the college. Okay, without applying any reasoning or without applying any decisions, without taking any decisions. Blindly we'll follow one path and we'll reach the destination. That comes under the knowledge level. Second one is the logical level. At this level, we understand that how the knowledge representation of the knowledge is stored. That means sentences are encoded into different logic. In the first level, the sentences are not encoded. That are the formal statement, as if we consider the KBA as a machine. But in the second level, what happens, the knowledge will be encoded into different logics, like using proposition logic or predicate logic. The same example we will take at the logical level, we can expect to the automated taxi agent to reach the destination B. But he or she may take, or here the agent will take the shortest path. If we take the example of a human being will take the shortest path. He will or she will apply the reasoning to find out the best path from A to be, not the at the knowledge, not like the knowledge level. Here the logic will be applied. The same thing here, to infer any result or to derive any conclusion in the best way, the agent will try to represent the knowledge using different knowledge representation technique. That is why it will be encoded into different logics to derive the conclusion. And the third one is the implementation level. So this is the physical representation of the logic and knowledge. Whatever the reasoning logical agent applies and whatever the knowledge it stores inside the knowledge base, it will be encoded in the form of language or in the form of programming language. So at this level, it performs the action as per the logical and the knowledge level. Now you can see the example, an automated taxi agent actually implement this knowledge and logic so that he can reach to the destination. If you write the same code, the same knowledge I can write using the Python language, the same knowledge I can write using C language, the same knowledge I can write in different language. Or if I have good programming skill, I can reduce the lines of code which will take less time and less space also. So depending upon the time complexity and space complexity, the output also it may be effective or it may be optimal. So which comes under the implementation level. So this is the way the knowledge based agent can be viewed at the knowledge level, at the logical level, and at the implementation level. Then we'll discuss about what are the approaches to design this knowledge based agent. Basically, there are two approaches are used to build the knowledge based agent. First one is the declarative approach and second one is the procedural approach. So as the name it implies, the declarative approach, it focuses on explicitly stating facts and relationship in a structured way without defining how to use them, like normal statement without any logic. Normal statement, normal English like statement without any logic, that is called as the declarative approach. So it focuses on explicitly stating the facts and the relationship in a structured way without defining how to use them. So knowledge is typically represented in forms of rules, facts and logical statements, like in the form of proposition logic and predicate logic. Here the inference engine determines how to use the facts and to draw the conclusion from the set of facts or rules. Here you can see the example which comes under the declarative approach. A medical knowledge base may have these facts. Just this is a sample example I have given. If the patient has fever and sore throat, then it suspects that he or she may get a flu. Another fact we have given that if the patient has a cough, then suspect a respiratory infection. So these are the facts which are already stored inside the knowledge base. Then the inference engine will use these facts to derive the conclusion based upon the patient's condition. So basically, this type of declarative approach is used in expert systems, legal rule verification, logical agents where the adaptability and reasoning are essential. And the second approach is procedural approach, where a procedure is used, step-by-step procedure, or the rules or the algorithms or the programs which are used. So it encodes the knowledge as a sequence of instructions. As I told, in the declarative approach, it will not be coded. Only the knowledge will be represented in the form of English. Then that will be converted into the representation, either proposition logic or the predicate logic. But in case of the procedural approach, it encodes the knowledge as a sequence of instruction. That means in the form of program or procedures for performing the specific task. So knowledge is embedded. Here the knowledge will be embedded in the form of algorithm, functions or production systems. And execution procedures, it will be in the predefined way to achieve the goals, because normally the program will be executed line by line or at a time, as we already aware of it, because procedural approach follows the specific procedure which can be embedded in the form of algorithm, functions and production system. Basically best for a task with well-defined procedures like the mathematical computations and control systems. For these applications, this procedural approach is used in artificial intelligence. These are few applications of knowledge-based agent. As the agent is knowledgeous and it is a base, it is having full of knowledge, prior knowledge and past knowledge. So it can be used in various sectors or various domains like medical expert systems, The diagnose the diseases based upon the symptoms and the test result. Based upon the facts and the knowledge, the medical expert system can be considered as the knowledge-based agent, and it can diagnose the disease to derive based upon the patient's condition. Second one is the autonomous vehicle can also be considered as the knowledge-based agent, which can navigate by reasoning about the road rules and the sensors data. Here, the road rules and the sensors data are nothing but the knowledge inside the autonomous vehicle agent. And based upon the rules and the sensors data, it can navigate or it can prompt you the best possible path from source to destination. Third one, the intelligent tutoring system. It assists the students by reasoning about their learning progress. So many inputs would be there in the intelligent learning tutoring system or learning system. Also, it is also there like the knowledge based agent. They can assist the student for their progress or for their further studies. And the next one is the legal expert systems, which are used to analyze the contracts and identify the violations. So all these like medical expert systems, autonomous vehicle system, intelligent tutoring system, or legal expert systems, even our Alexa or the robot, all everything are considered as the knowledge based agent. Everyone is considered as the knowledge based agent because they have the knowledge and it stores the knowledge from the environment. Based upon the knowledge, it takes the inference engine, takes the decision, and it performs the action. I mean, it derives the valid conclusion from the existing knowledge. These are the references I have referred to prepare this video. Next class, I will discuss about one of the example of this knowledge-based agent, which is nothing but the Olympus Vault. Till I hope you might have enjoyed this video. I'll catch you in the next video. Till then, thank you. Bye.
Like, share and subscribe. Hit the bell icon for more updates.